Hello all, welcome to the Counting Well exam prep live session. So before we start the session, let me try to lift your spirit a little higher and boost your confidence a bit. For that, I have one motivational quote for you. Study hard no matter if it seems impossible, no matter if it takes time, no matter if you have to up all night. Just remember that the feeling of success is the best thing in entire world. We know that exam season is round the corner and the two most important aspects of scoring good are revision and practice. Remember that practice doesn't make you perfect but helps you to perform better. Planning beforehand allows plenty of time for your revision. And so we are here to shoo away your exam fear and help you revise your concepts before it's too late. So stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through two chapters: fractions and decimals, exponents and parts. So let us see the chapter fractions and decimals. Let us see how to visualize multiplication of proper fraction by whole number. Note that a proper fraction is nothing but a fraction having numerator less than its denominator. So here we have a proper fraction 1 by 5 and a whole number 3. So how we are going to represent it by using diagrams, or how do we represent this using figures? Here we have 3 holes with one part shaded out of the 5 parts. So one whole is first divided into 5 parts because we have 5 in the denominator. Then we have shaded one for each whole out of the 5 parts. So we have 3 into 1 by 5. That's why the resulting figure will have 3 parts out of the 5 parts. Let us see multiplication of fractions. When you want to multiply fraction by a whole number, then there are some cases. Either the fraction will be proper, or the fraction will be an improper fraction, or the fraction will be a mixed fraction. So when you are multiplying a proper or improper or mixed fraction by a whole number, you have to follow these steps. So when a proper fraction 5 by 18 is multiplied by whole number 3, you multiply that whole number to the numerator. So we have 5 into 3 divided by 18. So we have 15 by 18. Then we find the simplest form of this fraction by dividing the numerator and denominator by a common factor. So here the common factor is 3. So dividing the numerator and denominator by 3, we have 5 and 6. So we have 15 by 18 equals to 5 by 6. Now let us see how to multiply an improper fraction by a whole number. We multiply the numerator by the whole number and we write the denominator as same. Then we write the resulting fraction in its mixed form because we have got here improper fraction. Next, let us see how to multiply a mixed fraction by a whole number. So mixed fraction multiplied by a whole number, we have to convert the mixed fraction into improper and then we have to do the multiplication. So we multiply 9 with 3 and then we have 27 by 7. Converting into mixed fraction, we have 3 6 by 7. Let us see how to multiply a fraction by another fraction. So product of two fractions is nothing but product of numerators and the product of denominators. So here we have two fractions, 2 by 7 and 5 by 3. And hence, by multiplying respective numerators and denominators, we have 10 by 21. Now let us see how to find a fraction 1 by 5 of 10. So fraction of 1 by 5 of 10 is nothing but by multiplying 10 to 1 by 5. Now let us find value of a product in case of two proper fractions and in case of two improper fractions. When we have proper fractions, the value of the product will always be less than each fraction given. So we have 1 by 10 less than the given fraction 1 by 2 and 1 by 10 less than 1 by 5. When we have product of two improper fractions, it will be greater than both the fractions. So 63 by 10 will be greater than 9 by 2 as well as by 7 by 5. Now let us see how to find reciprocal of a fraction in case of proper, improper or the mixed fraction. So whenever we want to find reciprocal, we interchange the numerator and the denominator. So reciprocal of 7 by 11 is equal to 11 by 7. Now to find the reciprocal of a mixed fraction, we first convert it into improper and then we find the reciprocal. So converting 3 1 by 2 by improper, how do we convert? We take the product of 3 and 2, then we add it to 1. So we have 3 2s are 6, 6 plus 1 is 7, 7 by 2, and its reciprocal is 2 by 7. Next, let us see how to find the division of fractions. We can divide a whole number by a fraction by a whole number, a fraction by another fraction. So let us first divide a whole number by a proper or improper fraction. Since 5 is a whole number and we are dividing it by a proper fraction, we take its reciprocal and instead of division sign, we take product. So instead of divide, we are multiplying by reciprocal of the proper fraction. So we get here 15 by 7. Converting into the mixed form, we have 7 1 by 2. Dividing a fraction by a whole number is nothing but here we have improper fraction which is divided by a whole number. Here 2 is nothing but 2 by 1. Taking its reciprocal, we have 1 by 2. So division is now written as product by taking reciprocal. So we have 7 by 6, which can be written as 1 by 6. Let us see how to divide a fraction by another fraction. Dividing a proper or improper fraction by another proper or improper fraction, we have to follow the same rule. By taking the reciprocal of the divisor, here the divisor is 1 by 3. So its reciprocal will be 3 by 1. So we have 3 into 3, 9, 9 by 5, which is equal to 1, 4 by 5. Now let us see how to divide a whole number by a fraction, or a fraction by a whole number, or a fraction by another fraction. So whenever you're dividing a whole number by a mixed fraction, again you have to follow the same procedure. First convert the mixed one into improper, and then we take the reciprocal of the divisor, which is 7 by 3 here, and hence we will write the mixed form of the resulting number. To divide a mixed fraction by a whole number, again we are converting mixed fraction into improper one, and then by taking the reciprocal of the divisor and replacing the division sign by multiplication, we will get the division of the two numbers. Now let us divide a mixed fraction by a proper or improper fraction. Again the steps are similar. We have to convert the mixed fraction into improper, and then we have to multiply the reciprocal of the divisor to get the result. Same we have to do when we are dividing proper or improper by a mixed. You have to always convert mixed into improper or proper, and then we have to take the reciprocal of the divisor by taking multiplication sign. So we get the resulting answer as 9 by 20. Now let us see the multiplication of decimal numbers. We can multiply a decimal number by 10, 100, 1000, or we can multiply it by any whole number or by another decimal number. So let us see first example where we are multiplying 10 to a decimal number. So in this case, we have to shift the decimal point to the right by one place. So we can see here decimal point is here, and once we have shifted it to right by one place, we will get 0.028. While we are shifting by 100, we have to shift by two places. So instead of taking decimal point here, we will take decimal point before 2 and 8. So we have 0.28. To multiply by 1000, we have to shift the decimal point to the right by three places. So since the decimal point is here, shifting to three places, you will get the decimal point after the number 8 from the right side. Now let us see how to multiply decimal number by a whole number. We have 2.45 multiplied by 6. You have to follow our traditional method of multiplication, like 6 multiplied by 5, 6 multiplied by 4, 6 multiplied by 2, and then we have to place the decimal point. After looking at the decimal number given. So here we have decimal point after two digits from the right side. So we have 14.70. Next, multiplying the numbers by ignoring the decimal point. What I have said is you have to multiply 245 into 6. So the product has same number of decimal places as a multiplicand. Now let us see how to multiply a decimal number by another decimal number. First, you have to multiply the numbers by ignoring the decimal point. So we have multiplication as 41500. Next, you have to check after how many places the decimal points are placed in the respective decimal numbers, and then we have to add those number of decimal places of multiplier. So we have after three places from the right end, so 41.500. Now let us see for division what happens. If you want to divide by 10, we have to shift the decimal point to the left. In case of multiplication, we are shifting to the right. Here we are shifting to the left. So we have 20 divided by 10. You have to Assume that the decimal point is to the right side of 8. So we are shifting to the left by one place. So we have 2.8. Dividing by 100, shifting the decimal by two places. First, you have to assume that the decimal point is after 28. Dividing by 100, we have 0.28. Next, we divide by 1000. We have to shift the decimal point to the left by three places. So we have 0.028. Let us see how to divide a decimal number by a whole number. For this, you have to perform a long division and then you have to take care of the decimal point. So we have 7 ones are 7. You will take 6 and then you have to take 3 here. Then we have 7 9 are 63. You have to take the two digits down. So if there is a decimal point before any digit that is to be brought down after the dividend, we have to place a decimal point in the quotient before doing so. Here you can see after 13 there is one decimal point and we are going to copy down the numbers after the decimal point. So we are putting decimal point here after the number 1. Now to divide a decimal number by another decimal number, what we are going to do is we are going to multiply both dividend and divisor by powers of 10 and then we perform the long division method so that at least the divisor is free from the decimal point. Next, let us see some of the basics of the chapter exponents and powers. Exponents are nothing but repeated multiplication represented using exponents. So we have 5 into 5 into 5, which can be written as 5 raised to the power 3. So what are the parts of any number of this form, exponential form? The parts is base and the exponent. So here the base is 5 and exponent is 3. Let us see what is negative base raised to odd or even power. Whenever you have a negative base and it is raised to a odd number, you will get a negative number as a resulting product. And in case of negative base raised to even number, you will get a positive result. Let us see laws of exponents. Product law, quotient law, multiplying same powers, dividing same powers, and exponent 0. Product law says that if you have same base, we have seen what are base and what are exponents. So when you have same base but different exponents, and you have multiplication of both the forms, a raised a to the power m and a to the power n, then we add or we take the sum of the exponents. So 3 square into 3 raised to the power of 4 is equal to 3 raised to the power of 2 plus 4, which is 3 raised to 6. In quotient law, we have same base and different exponents. We take the difference in the case of division. So this law is nothing but quotient law since we are dividing, and this law is called product law since we are multiplying. Now what will happen if we have different bases but same exponent? In this case, we will take the product of the bases and raised to the exponent n. So if you have 3 square into 5 square, this will be nothing but 3 into 5 raised to 2. So we have 15 square. And if we have different bases, same exponents, and we are dividing these two numbers, then we have a by b raised to n. Also, let us see property for exponent 0. Any number raised to 0 is 1, except 0. We cannot define 0 raised to 0. So any number except 0 is 1. So 3 raised to 0 is 1. Similarly, 1000 raised to 0 is also 1. Let us see expanded form of a number using exponents and powers. So 12,345 can be written as 1 into 10,000, 2 into 1,000, 3 into 100, 4 into 40, and 5 into 1. Note that here 10,000 is written as 10 raised to 4, 1,000 is written as 10 raised to the power 3, 100 is written as 10 square, 10 is written as 10 raised to 1, and 1 is written as 10 raised to 0. Because 10, any number raised to 0 is 1. Similarly, 2005 can be written as 2 into 10 raised to 3 plus 5 into 10 raised to 1. Because the place value of 2 here is 2000, place value of 5 is 5. And we are writing 1000 as 10 to the power 3 and 1 as 10 to the power 0. Next, let us see what is the standard form of any large number. Any large number can be written as a raised to 10 raised to a into 10 raised to 9, where a lies between 1 and 10 and n is the power of 10. We usually use standard form for large numbers when we have to avoid big numbers writing on a page. So instead of writing 4 zeros after 15, we can write it as 1.5 into 10 raised to 4. For example, there is a large number. In case of distance between the earth and the moon, we have 6 zeros after 384. And since the number a should lies between 1 and 10, so we place decimal point here, and then we take the number of places after the number 3 to the power of 10. So we have 6, 7, 8. 8 numbers after the digit 3. So we write it as 3.84 into 10 raised to 8. Next, let us see some tricks for the exams for these two chapters. Whenever you are cancelling out common factors, note that when you're multiplying a fraction by a whole number, so you're multiplying a whole number, you have to cancel their common factors if they have any. So you have to find the common factors of 8 and 28 and divide these two numbers by that common factor. So we have 4 twos are and 4 sevens are 28. So we have 3 into 7 as 21, and 28 is nothing but 28 upon 1. So we have 2 into 1 as 2. That's why we have 21 by 2. This is again converted into mixed fraction. So we have 10, 1 by 2. Let us see for multiplication and division of decimal numbers by powers of 10. Let us consider our decimal number 5.608. Then students often get confused whether to shift the decimal point to the right or to the left. In which case we have to shift to the right, and in which case we have to shift to the left. So whenever you are doing a product, you have to shift the point to the right side by the number of zeros we have in the multiplicand. So here we have 5.608 multiplied by 100. So we will shift this decimal point to the right side by 2 places. So we have 560.8. And in case of division, we will shift it to the left side. So we have here 0.05608. So right for multiplication and left for division. Upon multiplication by powers, the magnitude of number increases and you must get a greater number as the answer. So note that when you're multiplying by 100, instead of 5.6, you're getting a larger number. And when you are dividing, you're getting a smaller number than a given number. So 5.608 here, and we have 0.05 here. Let us see shifting decimal points in multiplication. To multiply a decimal number, shift the decimal to right by one place. To multiply decimal number by 100, shift by 2 places. To multiply by 1000, shift by 3 places. So here multiplying by 10, we have shifted the decimal point to the right by one place. So we'll put the decimal point here. Here we have to shift by 2 places. So we have 0.28, and here by 3 places. So we have 2.8. Let us see how to place decimal points in multiplication. We have to first ignore the decimal point. So here to multiply these two numbers, you have to ignore the decimal points and then find the product. Then we have to place the decimal point by using this rule. So here, after how many digits have we put the decimal point? Yes, after one digit from right, and here after one digit from right. So we have two digits. So 12.13 into 0.6 is 7.38, because after two digits you have to place decimal point. Let us see shifting decimal points in division. To divide decimal number by 10, shift to the left by one place. So shifting to the left, we have 2.85. Here shifting to the left by two places, we have 0.285. Shifting by three places, we have 0.0285. Let us see trick to place decimal points while dividing. While dividing numbers, we go on with the division till we get 0 in the remainder. So once the whole numbers are exhausted, we should not forget to add decimal point in the quotient before adding 0 to the dividend. For example, here we have 2 ones are 2. So we get 0 here, and 1 is get down. Sorry, and 5 is get down. Then we are doing 2 into 2, 4. We have 1. Then we don't have any number, or the whole numbers are exhausted here. So we put a decimal point, and then we have 2 5s are 10. And in this way, we get the remainder 0. Let us see a trick for the faster calculation. The trick is to learn the squares and cubes of the first 10 natural numbers at least. So you have to learn what is square of 4 and what is cube of 4. What is square of 8 and what is cube of 8, and so on. Now, while solving complex expressions using law of exponents, we have to see the base of exponential numbers should not be prime numbers. So for such questions, the first step is to write the base as the product of the prime factors. So in this way, you can simplify the complex expression. So 12 can be written as 2 square into 3, 9 can be written as 3 square, and 4 can be written as 2 square. Why we are doing this? We have to simplify the expression using law of exponents. For that purpose, we are writing the base as product of their prime factors. So here you can see you can easily solve using the laws of exponents, correct? So you can cancel out the common terms here and solve the expression or simplify the expression. Let us see how to write large numbers in standard form. Note that 1 less than the digit count to the left of the decimal point in a given number is the exponent of 10 in the standard form. So what we are going to do is we assume the decimal point to be at the right end. So we assume The decimal point is here. Then we have to count the places to the left. So how many numbers are there on the left side? We have total 11 digits. So the exponent of 10 will be the number of digits minus 1. So we have 10. So we write it as 6.008 into 10 raised to 10. Similarly, to write 6855.7 in standard form, we observe that there are 4 digits to the left of the decimal point. So the exponent will be 4 minus 1. That is 3. So we have 6.8557 10 raised to 3. So this is the trick we are going to use while we are writing large numbers in standard form. Now let us see what are some common mistakes that students do. Whenever you're multiplying a fraction by a whole number, the whole number gets multiplied to the numerator of the fraction, not to the denominator. Okay, but here what they have done, the student has done a multiplication as 3 into 10, also 4 into 10, and the student has got the answer 30 upon 40. Or here the student has multiplied 4 and 10 and write the final answer. But the correct way is to multiply that whole number only to the numerator of the fraction. So this is the correct way. Let us see trick or what are the common mistakes students do while they're cancelling out the common factors. So common factors for 3 and 12 have to be found out instead of common factors of 8 and 12. Have I told it correctly? No. You should find common factors of 8 and 12 instead of 3 and 12 because here 12 has to be divided by 8. So the whole number 12 can be written as 12 by 1 and not 1 by 12. Now both 12 and 13 are in the numerator, so we cannot cancel. So this is the way we are going to do it. So we are getting 4 as a common factor for 8 and 12. So we have 4 twos are and 4 threes are. Then we are multiplying numerators 3 into 3. So we have 9 upon 2. One more student mistake is here, finding the reciprocal of the correct fraction. So note that the first number is the dividend, the second number is the divisor. Always remember that you have to find the reciprocal of the divisor, not the dividend. Here divisor is 1 by 3. So dividing 4 by 9 by 1 by 3 same as multiplying 4 by 9 by reciprocal of 1 by 3. Reciprocal of any number is written by interchanging its numerator and denominator. So we have 4 by 9 divided by 3 is equal to 4 by 9 multiplied to 3 by 1, which is equal to 4 by 3. So this is not the correct way of doing this division. Here a student has multiplied 1 by 3 directly by changing the sign division by the product. Let us see how care should be taken by multiplication and division of decimal numbers by powers of 10. Note that whenever we are multiplying, we have to shift the decimal point to the right side, and whenever we are doing division, we have to shift to the left side by respective number of digits. So here we have 100, that is 2 zeros. So you have to shift by 2 places. In case of 10, you have to shift by 1 place. In case of 1000, you have to shift by 3 places. Let us see how to place decimal points in multiplication. So the number of digits after decimal point here is 1. The number of digits after decimal point here is 1. So a student has put the decimal point from the right side, and before that decimal point he or she has taken only one digit, which is the wrong way. You should always take two digits because 1 plus 1 is 2. So after two digits from the right, you have to take the decimal point. Let us see how to take care while we are placing decimal points while dividing. So here the student has directly taken number 0 and has taken 2 5s are 10, and has forward that we have already exhausted whole numbers here and we don't have 0 here to take it down directly. So we have to take decimal point first and then place a 0, and then we are going to multiply by 5. We'll get 10 till we get remainder 0. So we have got the remainder 0 here. So we have stopped the division process. Now, students often get confused for the presentation of exponents and powers here. Here base is 11, exponent is 2. So 11 square is not same as 2 into 11. We have to take multiplication of 11 by itself twice, not 2 multiplied by 11. So this is the correct way, and this is not the correct way. Multiplying 2 to 11 or multiplying or adding 2 and 11. Also, minus 3 square is not same as minus 3 bracket square. The expression minus 3 square means we have to first multiply 3 together and then take negative of that answer. So it is minus of 3 square. So 3 square is 9 and minus of 9 is minus 9. And minus 3 whole bracket square means you have to multiply minus 3 twice. So minus 3 into minus 3 you will get 9 and not minus 9. So this is the correct way of finding minus 3 square, and this is the correct way of finding minus 3 whole bracket square. Also, 4 to the power minus 2 is not the same as minus 4 to the power 2. Here the 4 square term means multiplication by 4 2 times. In the same manner, 4 raised to minus 2 means division by 4 2 times. So the quotient here is minus 2. We know minus 2 is nothing but 0 minus 2. So we have here 4 raised to 0. And using quotient rule, we have 4 raised to 2. 4 raised to 0 is nothing but 1. So we have here 1 upon 4 square, which is nothing but bracket raised to 2. So 4 square is 4 into 4, 16, and 4 raised to minus 2 is not same as minus 4 into 4. In fact, 4 raised to minus 2 is equal to 1 by 4 whole bracket square. Also, 3 square is not same as 2 cube. Here you can see the difference is the base is taken as exponent here and the exponent is taken as base. So 3 square means 3 multiplied 2 times, whereas 2 cube means 2 multiplied 3 times. So 3 square is 3 into 3, which is 9. And 3 square doesn't mean 2 multiplied 3 times. 2 raised to cube is 8. Let us see how to take care while you are writing the expanded form of number. You have to check the digits in the number. You have to check the place value of 2, place value of 5, place value of 6. So 2 is in the hundreds place and third number from the right. So its place value is 2 into 100, that is 200 and not 2000. Also 5 is in the tens place, which is second number from the right. So its place value is 5 into 10 and not 5 into 100. Place value of 6 is 6 into 1 and not 6 into 10. Hence expanded form is 2 into 100 plus 5 into 10 plus 6 into 1 and not 2 into 1000 plus 5 into 100 plus 6 into 10. Okay, here 6 raised to 5 into 6 raised to 20 is not equal to 6 raised to 100. We have to apply here product rule. Product rule is for same basis and different exponents or same exponent. But the only condition to apply the product rule is that the base should be same. So your base is 6 and we are taking product. So we have to take the sum of the exponents, not the product of the exponents. So for any integer k, k raised to p into k raised to q into k raised to r is k raised to p plus q plus r. Means no matter how many times numbers are multiplied having same base, you always have to add their exponents by taking the base as it is. So 6 raised to 5 into 6 raised to 20 is equal to 6 raised to 25, not 6 raised to 100. Here a student has done 5 into 20, that is 100, which is wrong. You have to do 5 plus 20, even if you have the multiplication sign here. 2 raised to 0 is not 0. So in hurry burry, a student can write 2 raised to 0 as 0. Note that any non-zero number, I have notified it before also, that you should take a non-zero number raised to the exponent 0, then you will get the result as 1. So any non-zero number raised to 0 is 1, not 0. Let us see some exam tips. You have to practice questions from NCERT textbooks, exemplar, other textbooks, and from previous year question papers, so that you will get a confidence that already you have solved and practiced a lot of questions, and then you will be ready to face any kind of question. You have to note down all the definitions and properties separately, so that before going to the exam you can glance through them and you will have clear idea on where to use which property. You should always avoid calculation mistakes while you are applying laws of exponents, especially when you have to apply the product rule or quotient rule, and when you have to apply rules for different bases raised to different exponents or same exponents and so on. So all the laws of exponents should be understood with clarity. Always express the final answer in its simplest form. Simplest form is nothing but you have to write that if you have got improper fraction, then you can write it in the mixed form. Or if you have a proper fraction, then you have to make sure that there is no negative sign in the denominator and there is no other common factor for numerator and denominator other than 1. Also, do not forget to place a decimal point after multiplying and dividing. You know that when you are dividing numbers with decimal points or decimal numbers, you are ignoring the decimal point, at least in the dividend. So you have to take care of the decimal point for the final result. Also, while solving word problems, you have to find out what is given in the question and what you have to find in that question. So this helps in identifying which law you have to apply or which rule you have to use for solving that problem. Practice more and more problems on simplifying complex expressions using law of exponents. You have to take the product of prime factors in order to use laws of exponents. So you have to practice how to find the prime factorization of any number. Also, you have to read the question very carefully and understand it. At last, you have to check whether you have also answered all the questions and parts of the questions. I hope this session was helpful, and if you want to quickly revise the concepts, practice some extra questions and sums, and also take a quick test, then Counting Well Prep Kit is here. Counting Well Exam Prep Kit lets you quickly glance through the major concepts of your chapter. You can also glance through solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks and the common errors that you make, etc. Over 75,000 students trust Counting Well for their maths learning. Even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well and learn more tricks and tips and ways to avoid common mistakes. We will be revising the chapters Data Handling and Algebra from class 6 in our next live session tomorrow, that is Friday. Till then, keep learning and keep growing. Thank